Hello dear students, I am Chetan Singadia from Dr. Subhash Technical Campus. You are watching the video lecture series for the subject of Database Management System. Today we are going to see Relational Algebra in DBMS. In this video lecture, we are going to discuss Relational Algebra. What is Relational Algebra? There are the operations are available in Relational Algebra like selection operations, projection operation, rename operation, union operation, set difference, intersection, Cartesian product. We would like to see the join operations. In that there are three categories. One is the inner join, natural join and outer join. In inner join we are going to discuss the theta join and equi-join. Then we are going to see the natural join, and we would like to see the outer join. There are three types of outer join operation: left outer join operation, right outer join operations and full outer join operations. So now let us start with the relational algebra and what is relational algebra in DBMS. Relational algebra is a widely used procedure query language. Now till now in SQL in DBMS what we understand in the form of SQL is what? SQL is a structured query language, or we can say SQL language, but in case of relational algebra it is called as a procedural query language. The form of procedural query language will look like different than SQL query. That we will see with the example in our upcoming video. Also it collects the instances of relations as an input and gives the occurrences of relations as an output. Now here I am going to explain is that in relational algebra there are two things. One, here we are discussing about the input, and other we are discussing about output. Now as a form of input, what it will take? In the form of input it collects the instances of relations, or we can say a table, and it gives the occurrences of relations, or we can say tables, in the form of output. Now it uses various operations to perform these actions. That means in the relations algebra, if we would like to perform this kind of things, then we have to use many type of operations. Like in SQL, relational algebra query operations are performed recursively on a relation. The output of this operation is a new relation which might be formed from a one or more input relations. So this is what a simple definition or simple understanding of relational algebra in DBMS. Now let us understand the basic SQL relational algebra operation, or we can say a basic relational algebra operation. Actually this relational algebra can be divided in various groups. Like it can be divided into three groups that I listed here. One is a unary relation operations, second one is a relational algebra operations from a set theory, and third one is binary relation operations. Now that each category has some sort of operations. Like if you are talking about the unary relational operations, then they included selection operations, projection operations and rename operations. Like in relational algebra operations from the set theory, in that they are going to explain the union operation, intersection operations, set difference, or we can say difference, and a Cartesian product. Actually these set operations we already understand in the form of mathematics also. And the last one is binary relation operation. In that we are discussing about the join operation and division operations. So this is how this each and every operations is supposed to be grouped in a various heading, like unary, relational algebra from set theory, and binary relations. So in the examination they may be asked about the all the operations, or they may be asked about the any one of them, unary relation operations, or they may be asked about the relational algebra operations from set theory only, or they may be only discussing about or talk about the explain or describe the join operations with example. So let us start with the each and every operations. Now let us talk about the first operation, that is select. So what is the use of selection operation, or we can say select operation in a relational algebra? The select operation is used for selecting a subset of tuples according to the given selection condition. So what is the use of selection operation? The use of selection operation is that when we want to select a subset of tuples according to the given condition, in that case we are going to use this selection operation, and for that we are going to use this sigma symbols, which is this selection operation is denoted by this sigma symbol. It is used in expression to choose the tuples which meets the selection conditions. Also, the select operator select the tuples that specify a given predicates. Now, here you can see that selection operations are there. Here I am talking about the three things. This this symbol is a selection operation symbol. This is a predicate. Now that predicates means what? This is a condition. This is what we are going to use as a condition. Then this entire thing we can call it as a condition. This is the symbol of selection operations, and this entire thing with P is called as a predicate, and this bracket R, that is indicated as a name of a relation or a name of a table. So this is what this sigma is a predicate with the selection symbol, and R stands for the relationship, which is the name of the table, and P is a propositional logic, or we can say condition, that we are going to use for a given condition in a selection operation. So this is what in basic understanding of selection operations in DBMS. Let me explain once again what is the use of selection operations. The selection operation is used to select the subset of tuples according to the given condition. We are going to denote this selection operation with this sigma symbol. Now, if we want to write an expression or a procedural query language, then we are going to use this expression, a sigma symbol. Then we are going to use this predicate, that is nothing but propositional logic, and in the bracket we are going to use this relation. So this is how we can form a query with the help of selection operations. Let us see the example also. Now here I have taken three examples. What is the first example is? The first example is we would like to select the tuples from the tutorials. The tutorial is nothing but our relation, or we can say table name, where topic name is database. This is what our query. This is what our output that we want. What we want where in our tutorial table, where the topic name is database, such kind of records we want in the form of output, but we want that query to be written in a procedural query language. Now what is the meaning of procedural query language? In that we are going to use some sort of relational algebra symbol. So how that particular thing that we can write in a relational algebra? So to express this query, we would like to use this this sigma symbol first, then propositional logic means what we want topic, that is our P. This topic is nothing but our P. So as in the form of topic, what we want database. So topic is equals to database, from where in which table? So that we have to write down in this bracket. So our table name is tutorials. So this is how we can write the query, a procedural query for the selection operations. Similarly, let us see another example. Select the tuples from the tutorials tables, where the topic is database and author is guru. Here we have to write down the two conditions. So what we have to do, just simply we have to write down this AND operator. Select the topic is equals to database and author. Select the topic is equals to database and author is equals to guru. From which table? Tutorials table. So this is how simply we can write down the procedural query language with the AND operator. And let us see one more example, that is example number 3. And what we want in that, we want to select the tuples from customer table where sales is greater than 50,000. So we have to simply write down select sales greater than 50,000 from customer. So according to the records it will be displayed. So this is how differently we can use the selection operations according to the procedural query language, and this is what selection operation in DBMS. Now let us talk about the projection symbol. Now that projection operation can be denoted by pi. Now this projection eliminates all the attributes of the input relation. What is that? The projection operation eliminates all the attributes of the input relation, but those mentioned in the projection list. The projection methods define a relation that contains vertical subset of relation. This is very much important line. The projection method, that means this projection operation defines a relation, defines a table that contains a vertical subset of a relation. That means the projection operations, whenever we are going to write the procedural query language in the with the use of projection operation, that always gives the output is the vertical subset of relation, or we can say column of that relation. One more important thing, this helps to extract the value of specified attributes to eliminate duplicate values. So this is once again an important point. It helps to extract the values of specified attributes to eliminate the duplicate values. This pi symbols, as I already said to you, this pi symbol is used to choose the attribute from a relation, and this operator helps you to keep specific columns from a relation and discard from the other columns. So this is what a simple understanding of projection operation in DBMS. Now consider this example for the projection operation. Here we have taken the customer table example. In that we have taken three columns. One is the customer ID, customer name and status. In that we have entered 4 records. So this is our example. We will see how it will be executed. Now from that example, what we want here, the projection of customer name and status will give. That means what we want from that table, we want from the customer table, we want the only customer name and status. So actually we have defined it three column in that particular table. Now out of the 3 column, we want only 2 column. Let's see, here you can see there are 3 columns, but what we want this 2 column, customer name and status. So this is what, so how that procedural query for the projection operation we would like to use this projection operation, and then this 2 column, customer name comma status, from which table, customer, and after executing this query manually, it will give the output like in this manner. So here you can see, according to the projection symbol, it will give the vertical subset of a relation or a table in the form of output. So this is what an example of projection operation. Now next operation, that is union operation, and that is denoted by something like U. A union is symbolized or denoted by a U symbol. It includes all the tuples that are in table A or relation A or in relation B. It eliminates the duplicate tuple. This is important line. As far as this union operation is concerned, whenever we are using union operation, it always eliminates, it's always remove the duplicate tuples when we are going to use this union operation for any example. So the set A union set B would be expressed. That means whenever we are saying how the union expression can be executed, if you are saying that set A union set B, and that can be expressed like A union B, this is how it will be right in the form of union operation. Now for a union operation to be valid, the following condition must be held. So whenever you would like to write the valid union operation, these are the following conditions that you have to keep in our mind. First, the R and S, that R and S is nothing but we have taken as a table name for the sake of simplicity. R table and S table must be the same number of attributes. R table and S table must be the same number of attributes. Also, the attributes domain needs to be compatible. The third one, duplicate tuple should be automatically removed. So these are the 3 conditions that we have to keep in our mind while using union operation. Now let us see that union operation with the help of example. Here you can see there are 2 tables, table A, in that we have taken 2 column, column 1 and column 2. In the column 1 we have taken these 2 records. Similarly, we have taken another table, in that we have taken 2 column. Now after merging this column, after giving the union operation, you can simply say that it will remove the duplicate record. So here you can see that 1 1, so that comes once, that's 1 2, that comes 1. Now let me explain once again this table A and table B. Here you can see there are 2 columns in table A, similarly there are 2 columns in table B. So what we have said in a union, so according to the union, duplicate records will be removed, data should be compatible, and duplicate records should be removed, and that data should be compatible also. So here you can see whenever we are going to union this both the table, the duplicate records means how many times the duplicate record will appear in these 2 table after using the union operation. Here you can see this records comes 2 times, one time in this table A and second time in table 2. So that one record is actually repeated, so that we are going to write down in a once, not twice. So that once with that record is eliminated or discarded, and another that is 1 2. So that is first time that we are writing 1 1, that is 1 1, 1 2, that is 1 2. Then 1 1, that record is eliminated because already from the table A that record is available from after union operation, and then another one is a 1 3. So after executing this this union operation from table A and table B, from A union B gives such kind of tables. So I hope this is very much easy to understand the union operations with the help of this example. Now let us understand what is intersection operation. So you see that intersection operation is denoted like this way, and intersection operations is defined or denoted by the symbol like this, A intersection B. This is how we can write mathematically. That defines a relation consisting a set of all tuples that are in both table A and table B. However, A and B must be a union and compatible. So what is the use of intersection operation, or how it will be executed? So whenever a relation consisting of a set of all tuples but they are in both, so whatever the tuples are there in a table A or table B, the common tuple or common row will be executed, because that is the actual meaning of intersection. Here you can see in this figure also there is a table A and table B. Now after doing the intersection, which portion is executed? Only matching rows or only matching tuple. Here you can see that is highlighted in red color. This many records are only executed, and this many records meant what? That all the tuples that are in both relation or both table, or only those matching values. So that is visual definition of intersection operation. Now let us understand that thing with the help of example also. Here you can see there is a 2 table A, table B. In that table A we have taken 2 columns. Similarly we have taken 2 columns in table B also. After intersection these two, what is the main use of intersection? The tuples or the matching rows will be executed. That means whatever the records are there in table A and table B, only the matching rows will be executed, no other row will be executed. So here you can see there are 4 records, 1 1, 1 2, 1 3, 1 1. The matching records are the first row. So these records will be executed after doing the operation of A intersection B. So this is what a simple understanding of intersection operation in DBMS with the help of an example. Now let us understand what is set difference. That set difference operation, we can simply say the difference operation also in relational algebra. The symbol denotes it with this minus. The result of A minus B is a relation which includes all the tuples that are in A but not in B. This is what the main meaning of this A minus B. What they are saying, the result of A minus B is what? The relation which includes, that means after doing these operations, the output that we are receiving is what? We are fetching the record is what? It includes all the tuples, that means all the rows that are in A but not in B. So this is what the main meaning of set difference. We will see that with the help of example also. The attribute name of A has to match with the attribute name in B. The two operands of relation A and relation B should be either compatible and union compatible, and it should be defined a relation consisting of the tuples that are in relation A but not in B. So this is what a simple understanding of set difference. Now let us understand set difference with the help of example also. Here you can see there is one example, table A and table B. Similarly, that previous example we have taken here. In both the tables we have taken two columns. The same records are available. So what we have to understand, A minus B, the records are available in table A but that not exist in table B. So after seeing this both the records, let me explain once again what is set difference or only difference operation in a relational algebra. The records, after executing this A minus B, what is the meaning of A minus B, or what is the meaning of A set difference B or A difference B? The value or the records or the tuple of A is available on table A, or we can say the relations A, the records are available in A but that records are not available in B. So after seeing this record, here you can see this record is available in A but not available in B. So that records is executed. But one more question will arise. So here this record 1,3 is not also available. This is also not available. But what we are doing in this operation, we are doing A minus B. So we are considering the table A, the records that are available in table A. So we are writing 1, 2. But if we are writing B minus A, so we are writing 1, 3, because so that we have to write down like that, where the records are available in table B but not in A. So that output maybe look like 1, 3. So this is how that set difference will executed manually in relational algebra. Now let us understand the next operation, that is Cartesian product, and that is denoted by this cross product. We already are aware of the fact that relations are nothing but a set of tuples, and here we will have two set of tuples. On applying Cartesian product on two relations, that is on two set of tuples, it will take every tuple one by one from left set relation and will pair it with all the tuples in the right side of relation. That means here I am going to explain is, whenever we are going to use the Cartesian product, we have a two relation, and that every relation of pair from each relation, that is supposed to pair with another relation. This is what they are saying. So the cross product or a Cartesian product of a two relation, that relation A, the records are R1, R2 till Rp with degree P, and B as S1, S2 and S3 till Sn with the degree of n, is a relation C R1, R2, R3, Rp and S1, S2 till Sn with the degree of P plus n attributes. So the cross product is a binary set operations, means at a time we can apply operation on two relation. At a time we can apply relation on two relation, but those relations on which we are performing the operation that do not have same type of tuples, which means union compatibility or type compatibility of two relations is not necessary. So let us understand this Cartesian product or a cross product with the help of example also. Now here you can see there is a example of Cartesian product. That notation can be denoted by this way. This S cross R, this S is a one relation and R is a, here this sake of simplicity, S can be called as a relation, R can be called as a relation, where S and R are the relations. This symbol X used to denote the cross product operator. Now considering these two relations, students, whereas a student has three columns. One is a student number, a first name and last name, and there is another relation that called or a table, that is a detail table, and that have a two column roll number and age, and such kind of records are exist in both the table. So now what we have to do, we have to do the cross product of student cross detail table. Let's see how it will be executed. Here you can see there are in both the table, student table and detail table, both have a 2 records. So according to the cross product, it is 2 cross 2. So we will have a total of 4 records. Let's see how it will be executed. Now let's see, on applying cross product or a Cartesian product on student and detail table or a student and detail relation, it will be writing like this way: student cross details, and there are 5 columns. After doing the cross product, here you can see the first 3 column, S number, F name and last name are from relation student, and roll number, age are from details. Now after doing the cross product, we have to write down simply merging both the tables. Now according to that table, we have to write down each records once. 1 Albert 5 with roll number 5 and 18. Similarly, that we have to write down with the another records, 1 Albert Singh 9 and 21. So after doing this operation of cross product, we will total number of records that we are total number of tuples that we are getting, that is 4. Now once again let me show the example table. So here you can see 1 Albert Singh 5 18, 1 Albert Singh 9 21, and 2 Noora Fatehi 5 18, 2 Noora Fatehi 9 21. Let's see that output table once again. 1 Albert Singh 5 18, 1 Albert Singh 9 21, 2 Noora Fatehi 5 18, 2 Noora Fatehi 9 21. So this is how the table will be executed in the form of Cartesian product with the using of Cartesian product. Now we can observe that the total number of tuples in relation 2 is 2, relation is 2, and the number of tuples in detail also is 2. So the number of tuples in a resulting relation on performing cross product is 2 cross 2, that is nothing but total number of tuples, that are 4. So this is what in generalized form of Cartesian, generalized form of understanding of Cartesian product. So whenever we have any two relations, so if anyone will ask when we are doing the Cartesian product, how many number of tuples are there? So just we have to, what we have to do, we have to count the total number of rows in a tuple relation 1 that we have to cross with the total number of rows in table 2 or relation 2. If we are combining, or if we are doing the cross product of that two records, then we are supposed to get the final total number of tuples from the after getting the Cartesian product. So this is what and simple understanding of Cartesian product, or we can say cross product in relational algebra. Now let us understand join operations. This is very much important example, a very much important concept. The join operation is essentially a Cartesian product followed by selection criteria, and that join operation is denoted by this symbol. Join operations also allows joining various related tuples from the different operations. Like the types of joins are there, from various form of join operations are available. For inner joins, there are actually two types of join: inner joins and outer joins. In inner joins, we can talk about theta join, equijoin and natural join. In outer join, we are going to discuss about the left outer join, right outer join and full outer join. Now let us discuss this inner join. In inner join, only those tuples that satisfy the matching criteria are included, while the rest are excluded, that means discarded. Let's study the various types of inner join. The first one is theta join. The general case of join operation is called theta join, and it is denoted by this theta symbol. And notationally we can write down relation A theta join relation B. The theta join can use any condition in the selection criteria. So this is what a simple definition of inner join in for the sake of understanding of theta join in a form of inner join. Now let us understand how the theta join will be executed in the form of example. So here you can see we have taken this example of table A and table 2. In the both the table, once again we have taken two columns, and in the each table we have inserted 2 records. So if you want to write down A this symbol of join, and this is this entire condition, this is relation A and this is relation B, and this is join, and this entire condition A dot column B greater than B dot column 2. This entire condition is called theta. This entire condition is called, or we can say, predicate. So this is our theta join. This symbol with this condition is called theta join. So relation A with theta join relation B. After doing this operation, so what we have to do? We have to do from A dot column 2. That means table A column 2 is greater than B dot column 2. If it is yes, then that condition will be executed. So firstly we have to write down this condition. It will be executed this condition from table A. After executing this condition, from A dot column 2 is greater than B dot column 2, that meaning of the theta join is it will select the tuples of table relation A, and it will be printed of column 2 from table A. That's why I have highlighted also this records is will be displayed in this column. So this is what simple theta join with an example. Now let us understand what is equijoin. When the theta join uses only equivalence condition, it becomes equijoin in a join operations. What is that? When theta join uses only equivalence condition. So here you can see this is a equivalence condition, and then it will become a equijoin. So relation A equijoin A dot column 2 is equals to B dot column 2, and this is from relation B. Now we have taken this example from previous our example, so we have to write down what. So whatever the common records are there in both the tables, that we are going to display in with the help of this equijoin. And this equijoin is the most difficult operations to implement effectively using SQL in RDBMS. One reason is why RDBMS has essential performance problem. So the theta join as well as equijoin are difficult to perform in the form of SQL. So in the real world, generally we are using the outer join, that is left outer join, right outer join, and full outer join, for the sake of simplicity in real world application. But for the understanding purpose, we have to understand how equijoin will be executed and how theta join will be executed. Now next operation is natural join, and natural join is denoted by this symbol. Natural join can only be performed if there is a common attribute. That common attribute is nothing but column between two relations. Let me explain once again. Natural join can only be performed if there is a common attribute between the relation. That common attribute is nothing but a column of that particular relation. The name and type of attribute must be same. That means whenever we are going to execute the natural join, we have to keep in mind that there should be a common attributes between the relation, and also the name and type of that attribute must be same. So here you can see in this example, there is a table called C and there is a table called D. The name of the attribute, here you can see the name of the attributes, one of the attributes from both the tables must be same. So here you can see num are available in both the tables. So whenever we are doing natural join, any one of the column name must be same. Also the name and type of attributes must be same. The type of attributes, if I am saying it is integer, then that particular record should be a integer. It should not be allowed a character or any other data type. Now, so this is what we have in the form of example. There is a table or a relation called C, and there is a table or relation called D, and in the each table we have taken two column, num and square. Here also we have taken num and cube. Now after doing the natural join, if I am doing the natural join, then symbol will look like, the notation will look like C natural join D, C natural join D. So how it will be executed? It will match the tuples. Now if I am matching, how it will be matching? Here is a num, there is a num, then that column is matched. Here is a 2, here there is a 2, so that record is matched. So 2 that we are writing, because that num column, that common column that we are writing only once, and 2, 4, 8, because that column is matched. Similarly 3, so here there is a 3, 9 and 27, so 3, 9 and 27. So this is how this natural join will be executed in a relational algebra. So this is what a simple understanding of relational algebra with an example. Now let us discuss other join operations, that is outer join. In an outer join, along with the tuples that satisfy the matching criteria, we also include some of all the tuples that do not match the criteria. So these are the outer join mandatory conditions. What are that? They satisfy the matching criteria. Also, they include some or all the tuples that do not match the criteria according to the natural join operation. So let us talk about the left outer join, and that symbol is supposed to be denoted like this way. In the left outer join, operation allows keep all the tuple in the left relation. Let me explain once again. In the left outer join, operations allows keeping all the tuples in the left relations. However, if there is no matching tuple is found in right relations, then the attribute of the right relation in the join result are filled with null values. Now here you can see that a graphical representation of left outer join. There is a relation called A, there is a relation called B. After doing the left outer join, here you can see this portion, this relation A portion will keep as it is. According to this definition, it allows to keep all the tuples of the left. This cap is as it is, and these records are not displayed because all rows from the left table, it will only display the all rows from the left relation, and the records that are not matching, that will be represented by a null values. Let's see that with an example. Now using this left outer join, similarly there are two tables here we have taken, table A, table B, or we can say relation A, relation B. Similarly, if you want to, we have to keep in our mind that while we have to execute the join, we have to use this one of the column is common. So we have taken num column is common. Now according to the left outer join, what we have said, what we are doing, A left outer join B. That means A is our left table. So according to the definition of left outer join, these records of table A, that means the left table will completely printed here as it is. Here you can see 2 4 2 4 3 9 3 9 4 16 4 16. Now this thing is that we have done. Now what we have to see. Now we have to see how many tuples are matched. Here you can see there is 2 tuples are matched from num2 and num3. So num2 is associated with square 4. Which is cube 8, so that we have to write down, and similarly with 3 and that associated with 18, so we write down. Here there is no matching tuples with num4, so that particular records is represented by these days. You can write down the null values also according to the definition. So after executing left outer join, our output of both the relation or both the table will look like in this form. So this is what in simple understanding of left outer join in relational algebra. Now let us understand what is right outer join, and it is opposite to the left outer join. In a right outer join, operations allows keeping all the tuples in the right relation. However, if there is no matching tuple is found in the left relation, then attribute of the left relation in the join results with filled with the null values. Now this operation is something look like opposite to the left outer join. In the right in the left outer join, what we have seen, after doing the left outer join, the left table record will keep as it is. And after matching the with that record with the right table, if any matching records will not found, and that value will be represented by null values or dash. Similarly here also, if you have taken relation 2 table, after doing that thing, the right table of record will be keep as it is, and the matching tuples from the left relation are not found, and that will be represented by null values. So all the rows from the right table will be available in a right outer join. Let's see that with the help of example. Now here you can see in this example we have taken table A, table B, or we can say relation A, relation B. So after doing A right outer join B, A right outer join B. So what is the right, according to the right region, which is our right table? Our right table is B. So whatever the records are there, whatever the tuples are there in relation B, that will be printed as it is. Then after we are finding the matching tuples. So here you can see there are two matching tuples are there. from 2 and 3, so that we have written 4 and 9. So here you can see that fifth record is not matching, so that will be represented by dash value. So this is what and simple understanding of right outer join of relational algebra. Now let us understand what is full outer join in a relational algebra. In a full outer join, all the tuples from both the relations are included as a result, irrespective of matching conditions. That means it is quite a difference from right and left outer join. In right outer join, what we are doing, we are keeping right table as it is and only writing the matching tuples. And also the tuples which are not matching, that we are not going to put it in our table, in output table, and that will be represented by null values or a dash. In the left outer join, what we are doing, we will keep left table as it is, and the matching tables are not available in right table, that we are keeping as a null values or dash. We are represented with dash. But in a full outer join, we are included all the records. Just what we have to do in the case of simplicity, to understand the ease of simpleness of full outer join, the records or the tuples are not matched, all the records from both the tables are not matched, that will be represented by null entries or a dash entries. Let's see simply that example that we have taken, that we already know, a table A or relation A, table B or relation B. Here you can see we just write down all these things, 2, 3, 4, 5. So here you can see if record 2 is there, 2 here also in table B is also there, so this record is matched, so that we are write down 2, 4, 8. Then let us see about 3 is matched, 3, 9, 18. Then let us talk about this 4, 16. Yeah, but that 4 num number 4, that record is not available in this table B, so that value is represented by dash because there is no matching tuple. Similarly with 5, there is no matching tuple in table A, so that will be represented by a dash or a null value. So this is what a simple understanding of full outer join in relational algebra. Now let us differentiate the natural join and inner join for understanding of relational algebra. In natural join joins the two tables based on the same attribute name and data types. That inner join joins the two tables on the basis of column which is explicitly specified on clause. In natural join, the resulting table will contain all the attributes of both the tables but keep only one copy of each common column. In inner join, resulting table will contain all the attributes of both the tables including duplicate columns also. In natural join, if there is no condition specifies, then it returns the row based on the common column. In inner join, only those record will return which exist in both the table. The syntax of the natural join will look like this way: select star from table name, natural join table 2, and the syntax for an inner join will look like in this form. So this is how we can differentiate the natural join and inner join of relational algebra. So let me quickly recap or quickly let us know what we did till now in this video lecture. We understand the selection operations, projection operations, union operations, set difference and intersection operations. Also we have seen the Cartesian product, or we can say cross product. Also we have seen inner join, theta join, equijoin, natural join. We have also seen the outer join and the types of outer join, that is left outer join, right outer join and full outer join. So this is what and simple understanding of relational algebra in DBMS. Thank you all.